Testing before customers see problems. In this video, the objective of this video is to help business owners understand testing strategies and their importance. Essentially, helping them understand data testing and validation. So the key outcome of this video is essentially you'll have an idea of of what to do when creating a testing strategy and how to plan for it. So, why does testing matter? Imagine launching a plane without testing it. You filled it with passengers, flew it once, and hoped it worked. Crazy, right? But what's but that's what most companies do with AI. They build it, deploy it live, and hope it doesn't fail in front of customers. This video is about testing before customers see problems. Starting off with test coverage. So, what is test coverage? Test coverage is the extent to which your AI system has been tested across different scenarios, edge cases, and conditions before going live to customers. Leads us to the testing pyramid. What is the testing pyramid? The testing pyramid is the hierarchical testing approach with many unit tests, progressively fewer integrations, systems, UAT tests, and continuous production monitoring. So there are 5 levels of testing essentially. Each catches different problems. There's level 1, which is the foundation, which is unit tests. So what are unit tests? They essentially test individual components in isolation. For example, does this function return expected output for a given input? If input is null, does it handle gracefully? If input is edge cased, does it work? You know, the cost of conducting these tests could be free. The developers can write within minutes. And this accounts for 70% of the bugs, and the ROI is high. Level 2 is integration tests. Test components that are which is testing components that are working together. For example, an AI component gets data from database, processes, return results. Does the whole pipeline work end to end? Do components exchange data correctly? Now, the cost of these integration tests is a bit higher than than the previous unit tests, and the bugs caught could be cumulative. And again, the ROI for conducting these tests are high. Then there's level 3, which is system tests. These are tests. This is like essentially a test to complete system. The test to is This is basically testing the complete system essentially. You know, asking questions like, does entire AI system work under load? Does it handle 1,000 simultaneous requests? What happens with bad data flowing in? Do all components stay in sync? You know, and the ROI of these types of tests is, of course, really good. Then there's user acceptance testing, which is UAT. Where What is this? This is essentially real users test with realistic scenarios. For example, does AI recommendation make business sense? Would real customers accept this response? Does UI work as expected? Are error messages helpful? You know, the costs to conduct these tests are a bit more expensive, but they catch real world issues. Then lastly, there is the production monitoring, where where you essentially monitor in a live environment with actual customers. For example, are real customers experiencing problems? Is performance acceptable in real world? Are error rates acceptable? Is accuracy maintained? You know, of course, this is standard procedures, with costs a lot higher. The costs to conduct these tests are higher. And so, why the pyramid? Unit tests are cheap, run many, catch most problems. You know, um, integration, unit tests are cheap, run many, you catch most of the problems. The integration catches components issues, system catches performance, UAT catches the real world performance, the production catches everything else. And so essentially, we're looking in terms of pricing and the amount of resources put into tests. It goes from unit tests, which could be free, integration, higher systems, higher UAT, which is the user acceptance test, higher production monitoring, higher, and so on. And so, not doing adequate testing can result in customer facing bugs, reputational damage, and customer churn. So, essentially, you need all five levels. And so, think of testing like building safety. You need multiple levels. You know, I'll go again. Level one, which is unit tests, which are the individual components, are like testing individual car parts. Does this wheel roll? Does this brake work? Does this sensor respond? For AI, does this validation rule work? Does this transformation succeed? Does this calculation produce expected results? You know, and usually it catches most prob like 70% of the of obvious bugs. Level two, which is integration tests, which are essentially components working together, is like testing assembled car parts. The wheels plus brakes work together. Do the wheels and the brakes work together? Does the engine and transmission work together? Are all the systems integrated properly? Same with AI. You know, data validation and transformation, do they work together? Real-time layer and warehouse and the warehouse there, are they compatible? Do all the pieces feed correctly into the model? You know, where you test the complete system. It's like testing the complete car. Does it start? Does it accelerate? Does it brake? Does it handle? For AI, does AI make correct predictions? Does it handle edge cases? Does it respond fast enough? Does it scale to real volume? You know, just doing this test catches at least 90% of system bugs. Then there is level four, right? Which is user acceptance tests, which is where you test in real scenarios. It's like the test drive with the customer. Does customer like how it drives? Does it meet customer needs? Any surprises in real world use? For AI, do recommendations actually sell products? Do predictions actually help decisions? And are there any weird edge cases that break it? You know, and so conducting this test could catch probably 95% of user facing issues. Then lastly, there is the production monitoring, where you monitor with real customers. It's like following up with customer after purchase. Is the car still working? Any unexpected problems? Any degradation over time? For AI, are recommendations still working? Any accuracy degradation? Any unexpected errors? 99% of issues are spotted before major damage, you know, and like again, you need all five levels. And this leads us to, this leads us to um what specific tests should be run, starting with the first test, which is happy path. The happy path test It's like taking a car for a test drive on perfect roads. Um, Test the normal case, average average customer, the normal behavior, expected conditions. And then there's the example for recommendation AI, which is the customer, their average spend, their typical preferences, their behavior. They browse 5 items, buy one. Expected recommendation is relevant. This should always work. Then there's test two, which is edge case tests, where essentially it's like stress testing a car, tight turns, steep hills, emergency braking, test unusual scenarios. So the specific tests to run. Starting with test one, which is the happy path test. It's like the happy path test is essentially like taking a car for a test drive on perfect roads. You test the normal case, the average customer, the normal behavior, the expected conditions. Same with, for example, a recommendation AI. You look at the customer, you understand their average spend, typical preferences, their behavior. They browse 5 items, buy one. Their what's expected, the recommendation is relevant. This should always work. Then we have test two, which is edge case tests, right? It's like stress testing a car, tight turns, steep hills, emergency braking, test unusual scenarios, such as, the new customer, returning customer after 1 year, um, the customer with very high, low budget, the customer with unusual preferences. And so essentially, it's like, for example, the new custom with AI is, can the AI recommend without history? The high value customer, does it work for $10,000 purchases? The unusual preferences, customer buys both luxury and budget items. If any of these break, you found a problem before customers hit it. Then the third test is the data quality test, right? Testing how the car behaves with bad fuel. It's the same with AI. You test with messy data. You catch the missing fields, such as no emails, the wrong formats, the typos, duplicates, and the outliers. Does the AI still work, or does it fail silently? You want to know failures before production. Then there's the fourth test, which is the volume test. So essentially, it's like testing car performance on a highway after hours in traffic. You test with real volume, the 100 concurrent users, 1,000 concurrent users, peak traffic, and does AI slow down, crash, or degrade? Better to find this in testing than when customers see 30-second delays. Then lastly, there are regression tests. It's regression tests are like an annual car inspection, making sure nothing has degraded. You test after changes, such as update, for example, such with AI, updated data, the changed model, new features. Does anything that worked before still work? Many teams break existing functionality when adding new features. And so And so the best way to explain this, right, is like with essentially with the testing strategy, I'm going to provide like tell you speak of like a short story, give you like a short story of like a real case study. There was a company that learned this lesson the hard way where before testing they built the AI, they deployed it live and they just crossed their fingers. The first week it was great. It was 85% accuracy. The second week, someone finds bugs, recommends men's products to women. The third week, someone finds another bug, crashes on very large orders. The fourth week, new data breaks everything. So the cost of bugs found in production was customer complaints, which damaged trust, emergency fixes, lost revenue because of bad recommendations, and the reputation of having an AI that is broken. This resulted in a lot of lost revenue. And then after testing, what after they had started testing, they had created their testing strategy, the unit tests, every validation rule, integration tests for the pipeline, their systems tests for full AI pipeline, their user acceptance tests for real recommendation scenarios, and their monitoring to track accuracy. This resulted in 95% of the bugs caught before production, rare bugs caught in monitoring, customer experience consistently good, and their team confidence was high. And so the cost of testing was essentially it was high, but the ROI prevented much more resources being wasted essentially. And so the lesson here is essentially with this short little case study I'm telling you is that spend money on testing before, not on fixing problems after.